A towering naval vessel, pride of the Mexican fleet, crashed headlong into the Brooklyn Bridge, tearing steel and snapping masts like twigs. 2 lives were lost in the chaos, and an icon of American engineering was left scarred. But the real shock? This wasn't just an accident. It was a warning of what could happen anywhere outdated systems meet unforgiving forces. The Cuauhtémoc, a 297-foot steel-hulled sailing ship, showcases naval engineering that rivals the best in the world. Built in 1981 at Celaya shipyards in Spain, this 3-masted bark trains Mexican naval cadets while projecting maritime pride. Its 2,368 square meters of sails push it to 10 knots, with a 1,125 horsepower diesel engine for precision in ports. But in 2025, global shipbuilding giants like China were outpacing others, with advanced naval vessels boasting cutting-edge automation, while the US focused on retrofitting older fleets for resilience. The Cuauhtémoc, though reliable, relied on older systems, a contrast to China's tech-heavy designs. On May 17, 2025, docked at Pier 17 in Manhattan for a 254-day training cruise, the ship carried 277 crew, including 175 cadets, aiming for Iceland via a Bay Ridge fueling stop. At 8:20 p.m., under a New York harbor pilot, disaster struck. A mechanical failure, likely in the aging diesel engine, cut power and steering. Unlike China's newer ships with redundant systems, the Cuauhtémoc drifted backward at 2.3 knots, pushed by a 0.3 knot current and 10 knot winds toward the Brooklyn Bridge. This 1883 marvel, with its 1,595-foot span and 127-foot clearance, was a US engineering triumph. Yet its cables faced no match for modern Chinese megabridges built for extreme loads. As the Cuauhtémoc's glowing masts smashed into the bridge's underside, snapping violently, debris fell, killing 2 crew members and injuring 19. The US prides itself on enduring infrastructure, but this clash exposed vulnerabilities. Could the ship's dated systems or the bridge's age have been outdone by China's relentless engineering advances? This deadly collision raises questions about how nations stack up when steel meets steel. The Brooklyn Bridge, opened in 1883, redefined engineering. Designed by John Roebling, it spans 1,595 feet across the East River, with granite towers soaring 276 feet. Its steel cables, each over 15 inches thick, use 21,000 wires, a revolutionary method then. With a 127-foot clearance at high tide, it was built for ships to pass safely, now handling 145,000 vehicles daily. In 2025, the US celebrated its durability, unlike China's megabridges, like the 34-mile Hong Kong-Zhuhai-Macau Bridge, engineered with advanced composites and AI stress sensors to endure extreme conditions. The Brooklyn Bridge, reliant on century-old steel and maintenance, faced a test on May 17, 2025. The Cuauhtémoc, powerless, drifted backward, and all 3 of its 158-foot steel masts struck the bridge's underside at 8:26 p.m. The impacts snapped the masts, sending wood and rigging crashing onto the deck. 2 sailors died under the debris, and 19 were injured, some critically. The bridge's cables held, but bent railings and minor deck damage raised alarms. Could China's sensor-equipped bridges have shrugged off such a hit? Emergency crews swarmed Pier 17, evacuating cadets to hospitals as the ship blocked river traffic. The US Coast Guard launched an investigation into the ship's failure. Witnesses saw a haunting scene: string lights hung from shattered masts, swaying in the dark. The bridge, a 19th century icon, stood firm, but its age showed against modern vessels. China's focus on cutting-edge infrastructure loomed large. Its bridges and ships boast real-time monitoring that might have prevented this chaos. As investigators probed the wreck, they found clues pointing to a preventable flaw in the ship's aging systems, hinting at a gap the US and others must close to match China's engineering edge. The Cuauhtémoc's mechanical failure was a disaster waiting to happen. Its 1,125 horsepower diesel engine, a Caterpillar model from 1981, was built for reliability but lacked modern redundancy systems. On May 17, 2025, as the ship left Pier 17, a suspected fuel pump failure cut power to the engine and propeller, disabling steering. The rudder, dependent on hydraulic systems tied to the engine, locked up, leaving the vessel at the mercy of the East River's currents. China's modern naval ships, like its Type 055 destroyers, use dual-engine setups and automated diagnostics to prevent such failures, reflecting a $200 billion investment in naval tech by 2025. The US, while upgrading its Navy with similar systems, often relies on older vessels for training, much like Mexico's Cuauhtémoc. This gap in technology proved deadly. As the ship drifted backward at 2.3 knots, its 277 crew members scrambled to drop anchors, but the 0.3 knot current and 10 knot winds overwhelmed them. The collision with the Brooklyn Bridge was inevitable. The ship's 158-foot mainmast, made of reinforced steel, smashed into the bridge's steel deck, snapping under the force. Debris, including rigging and lights, rained down, killing 2 crew members, a 22-year-old cadet and a 35-year-old officer. The U.S. Coast Guard's initial report, released days later, pointed to neglected maintenance on the Cuauhtémoc's engine, a stark contrast to China's rigorous AI-driven maintenance protocols. The incident raised questions about global naval standards. Why was a 44-year-old ship without modern fail-safes navigating a busy harbor? The Brooklyn Bridge, though damaged, held strong, but its age sparked debate. Could China's newer bridges, built with composite materials, have avoided even minor damage? As New Yorkers watched the chaos unfold, the tragedy exposed a critical truth. Engineering marvels, no matter how grand, can fail when outdated systems meet unforgiving conditions. The U.S. Coast Guard's investigation into the May 17, 2025, collision revealed a cascade of failures aboard the Cuauhtémoc. The ship's 1981 Caterpillar diesel engine suffered a fuel pump breakdown, likely due to worn seals undetected during maintenance. This cut power to the propeller and hydraulic rudder, leaving the ship adrift. Unlike China's Type 055 destroyers, which use AI diagnostics to flag issues before they fail, the Cuauhtémoc relied on manual inspections, last completed 6 months prior. China's $200 billion naval program by 2025 prioritized real-time monitoring, while the US and allies like Mexico lagged in retrofitting older vessels. The investigation also noted the ship's backup generator failed to engage, a feature standard in modern Chinese ships, but absent here. This left the crew unable to regain control as the vessel drifted at 2.3 knots toward the Brooklyn Bridge. The collision's impact, 3 masts snapping against the bridge's deck, caused $2 million in damage to the ship and $500,000 to the bridge. The US, proud of its infrastructure legacy, faced scrutiny. The Brooklyn Bridge's steel cables, though intact, showed stress marks, unlike China's mega bridges, with composite materials designed for higher impact resistance. Engineers inspecting the bridge found bent railings and deck cracks, repairable but concerning for a 142-year-old structure. The incident highlighted a global race. China's rapid adoption of smart technology in ships and bridges versus the US's reliance on aging but tested designs. The tragedy, which killed 2 sailors and injured 19, sparked calls for stricter naval maintenance standards. Mexico's Navy vowed to overhaul its fleet, but questions lingered. Why wasn't the Cuauhtémoc upgraded with modern fail-safes? Could the US learn from China's tech-driven approach to prevent future disasters? As repairs began, a deeper issue emerged, one that could change how the world builds and maintains its engineering marvels. The collision of the armed Cuauhtémoc with the Brooklyn Bridge sent shockwaves through the engineering world, exposing gaps in global naval and infrastructure standards. The incident underscored the risks of relying on aging technology, a lesson China has sidestepped with its aggressive push for innovation. By 2025, China's $300 billion infrastructure budget dwarfed the US's $100 billion for bridge and port upgrades, enabling advanced designs like the Danyang Kunshan Grand Bridge, which uses self-monitoring materials to detect stress. The Brooklyn Bridge, a 142-year-old icon, lacks such tech, relying on manual inspections every 2 years. Similarly, the Cuauhtémoc's 1981 engine had no automated sensors, unlike China's naval vessels, which use AI to predict failures. The accident, costing 2 lives and $2.5 million in damages, prompted Mexico to invest $50 million in fleet modernization, including dual engine systems. The US, too, faced pressure to update its aging infrastructure, with 43,000 bridges deemed structurally deficient in 2025. China's approach, integrating smart tech into ships and bridges, offered a model, but the US prioritized cost-effective retrofits over new builds. The collision also sparked debate about harbor safety. New York's busy port, handling 7 million containers annually, had no real-time vessel tracking like China's Shanghai port, which uses AI to manage traffic. The Cuauhtémoc's drift could have been flagged earlier with such systems. Engineers now argue for global standards, blending China's tech-driven designs with the US's proven durability. The tragedy highlighted a stark reality. Even the strongest structures and ships can fail without modern safeguards. As the Brooklyn Bridge underwent repairs, experts questioned whether older designs could keep up with today's demands. The US and Mexico vowed changes, but China's lead in engineering raised a bigger issue. Could another overlooked flaw in a different harbor spark a catastrophe no one sees coming? The long-term fallout from the May 17, 2025, collision reshaped naval and infrastructure priorities worldwide. Mexico's Navy, stung by the loss of 2 sailors and $2 million in damages to the armed Cuauhtémoc, committed $50 million to modernize its fleet with dual-engine systems and AI diagnostics, mirroring China's Type 055 destroyers. China's $200 billion naval investment by 2025 set a high bar, with ships equipped with automated maintenance alerts, reducing risks of mechanical failures like the Cuauhtémoc's fuel pump breakdown. The US, with $150 billion allocated for naval upgrades, began retrofitting training vessels, but lagged behind China's rapid deployment of smart technology. The Brooklyn Bridge, repaired for $500,000, prompted the US to reassess its 43,000 aging bridges. Unlike China's Danyang-Kunshan Grand Bridge, which uses AI sensors to monitor structural health, the Brooklyn Bridge's manual inspections missed subtle stress marks revealed post-collision. Global harbor safety standards came under scrutiny. China's Shanghai port, handling 47 million containers annually, uses real-time AI tracking to prevent collisions, while New York's port, with 7 million containers, relies on human pilots. The Cuauhtémoc's drift could have been stopped with such tech. International maritime bodies proposed mandatory redundant systems for older ships, a standard China already enforces. The incident, which injured 19 and disrupted river traffic, fueled debates over balancing historic engineering with modern demands. The US and Mexico leaned on proven designs, but China's tech-driven approach, integrating sensors and composites, proved more resilient. Engineers worldwide called for hybrid solutions, combining US durability with Chinese innovation. As the Cuauhtémoc returned to Mexico for repairs and the Brooklyn Bridge reopened, a new question loomed. Could global standards close the gap before another tragedy strikes? The world watched as one tiny oversight hinted at a much larger problem waiting to surface in the next great engineering marvel. The legacy of the armed Cuauhtémoc's collision with the Brooklyn Bridge on May 17, 2025, redefined global engineering priorities. The tragedy, which claimed 2 lives and caused $2.5 million in damages, exposed the dangers of outdated systems. Mexico's $50 million fleet upgrade now includes AI diagnostics, inspired by China's Type 055 destroyers, which use predictive tech to avoid failures. The US, with 43,000 aging bridges, allocated $20 billion for retrofits, but China's $300 billion infrastructure push, including bridges with real-time sensors, set a tougher standard. The Brooklyn Bridge's manual inspections paled against China's AI-monitored structures, prompting calls for global standards blending US durability with Chinese tech. Harbor safety also shifted. New York's port began testing AI tracking, like China's Shanghai port, to prevent future drifts. The incident's ripple effect pushed international maritime rules, mandating redundant systems for older ships. The Cuauhtémoc's failure, a neglected fuel pump, showed even small oversights could turn marvels into disasters. As the bridge and ship were repaired, the world looked to China's tech-driven model, questioning if the US could keep up. This collision wasn't just a tragedy, it was a wake-up call for engineering's future. The Cuauhtémoc's collision exposed a fatal flaw in engineering giants. But as the world races to modernize, another iconic structure hides a secret weakness. One small miscalculation, ignored for decades, could bring a global landmark crashing down. Which engineering marvel is next, and what disaster waits in its shadows?